Ya, Pak.
Bapak Ibu, mohon untuk mengisi tempat duduk yang di depan terlebih dahulu, biar bagus kalau difoto sama di kamera. Izinnya, silahkan Bapak Ibu. Di sini masih kosong, Bapak Ibu. Yuk di depan, silakan. Biar bagus di kameranya. Sip. Silakan Bapak Ibu, di baris kedua masih ada yang kosong. Yuk, biar bagus gambarnya di Zoom. Ladies and gentlemen, we will start our webinar shortly. Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. I wish you have a very pleasant morning and serenity. Welcome to Sharing Session 2025 with the topic Knowledge and Data Engineering on Wednesday, 25th of June 2025. Held by Research Center for Data and Information Science, National Research and Innovation Agency of Indonesia. This webinar is conducted in hybrid format, both on-site in Science and Technology area Samaun Samadikun in Bandung, and virtually through the Zoom meeting application. And I'm Kristanti Permata VDRC, and I'll be served as the host of this sharing session. It's an honor for me to inform you that now as here we have distinguished speaker, Mr. Quang Vinh Dang from British University, Vietnam, distinguished chairman of Research Organization for Electronics and Informatics BRIN, Mr. Budi Prawara, distinguished head of Research Center for Data and Information Science BRIN, Mr. Esa Prakasa, distinguished moderator Mr. Wawan Hendriawan Nur from Research Center for Data and Information Science BRIN, and all participants and guests. And ladies and gentlemen, before we proceed our first agenda, I would like to invite all participants to rise and sing National Indonesian Anthem Indonesia Raya. Ladies and gentlemen, please be seated. At this moment, we are pleased to invite distinguished Head of Research Center for Data Information Science BRIN, Mr. Esa Prakasa, to deliver welcome remarks. To Pak Esa, the time is yours.
Thank you, Nanti, for time for the opportunity to providing the remarks. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. Firstly, Honorable Dr. Budi Prawara, the Chairman of Research Organization of Electronics and Informatics, National Research and Innovation Agency, BRIN. So, Honorable Speaker, Dr. Quang Vinh Dang from British University, Vietnam, and also Honorable Dr. Foni Agustiawan, Dr. Lindung, Dr. Satrio, and also the organizer team from the Knowledge and Data Engineering Research Group. And lastly, honorable ladies and gentlemen, researchers, and all participants that are joining this webinar, either in person and online. Firstly, as the head of Research Center for Data Information Sciences, I want to extend an extended welcome all of you, especially for our distinguished speaker, Dr. Quang Vinh Dang, in this sharing session today. Dr. Vinh will give a talk entitled Knowledge Graph and Large Language Models for Intrusion Detection. We know these two methods have their capabilities, the specific capabilities. The knowledge graph is stronger for structured reasoning, whereas the large language models can obtain the pattern structure through the learning process. By combining both methods as a technology solution, may we get several new advantages, such as improving accuracy and explainability, enhance reasoning and inference, and domain adaptation and personalization. Dr. Vinh will inspire us and provide a broad perspective on the implementation of knowledge graph and large language model. I hope all of us can get many benefits and new knowledge, and through this webinar, it can initiate a further research collaboration among us and also for all of the participants. Once again, thank you, Pak Budi, and also Dr. Vinh, and all of the participants for being here. And hopefully we can join the sharing session and can get a new perspective and new knowledge. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
We would like to express our gratitude to Mr. Esa for the welcome remarks. Ladies and gentlemen, it's an honor for us to invite distinguished Chairman of Research Organization for Electronics and Informatics BRIN, Mr. Budi Prawara, to deliver opening remarks. To Mr. Budi, you may take the floor.
Yeah, thank you. Assalamualaikum warahmatullahi wabarakatuh. Very good morning. The Honorable Head of Research Center for Data and Information Sciences, Dr. Esa Prakasa, our distinguished speaker, Dr. Quang Vinh Dang from British University, Vietnam. Ladies and gentlemen, distinguished guests, researchers, and practitioners. So first, I would like to welcome you, Dr. Vinh, to our Science and Techno Park, KST Samaun Samadikun. This is one of KST in BRIN. Actually, we have four big science and techno area in not only in Bandung, but there are in Jakarta, Serpong, and Cibinong also. But this science techno area is the smallest one. This is also our home base for research organization for electronics and informatics. Yeah, it is also my great pleasure to welcome you all to this timely and highly relevant webinar on the implementation of knowledge graphs and large language model for intrusion detection. Yeah, this is the remarkable event ya Pak Esa ya, sharing session 2025 with the topic of knowledge and data engineering. In recent years, the digital landscape has undergone an unpredicted transformation with the explosive growth of data and interconnected system. The complexity and scale of cyber threats have also evolved significantly, and traditional rule-based and signature-driven intrusion detection system are increasingly falling short in detecting sophisticated multi-step attacks. This has necessitated an paradigm shift in how we conceptualize the operationalized security measure, particularly in real-time threat detection and response. And today we find ourselves on the brink of new era, an era where knowledge graph and large language models offer powerful complementary capabilities to meet this growing challenge. Knowledge graphs enable us to model relationship between entities in rich, structured, and semantically meaningful way. And when we integrate with LLM, it's also capable to understanding and generating human-like language and inferring complex patterns. We begin to see the emergence of intelligent, context-aware systems that can detect and even anticipate the threat with a level of nuance previously unimaginable. This is where the integration of knowledge graphs and LLM present a transformative opportunity. And the synergy between this technology open up a new frontier in building context-aware, semantically rich, and protective intrusion detection system. Today, webinar brings an expert of intersections between cybersecurity, artificial intelligence, and semantic technology. Through his presentation, applied case study, and interactive discussion, we aim to explore not just what is possible, but what is practical and impactful. I want to extend my sincere appreciation to our distinguished speaker who has generously agreed to share his insight and experience. And I also thank to our organizing team who have made this hybrid event possible, ensuring that we can connect across time zone and continents. Your effort enable meaningful dialogue that transcends geographically boundaries. And for our participants, whether you are researchers, developers, cybersecurity analysts, and policy stakeholder, I encourage you to actively engage in today's session, ask questions, share your thoughts in chat, and connect with one another. The challenges we face in securing our digital ecosystem are complex and interconnected. Solving them will require collaboration, creativity, and shared vision. And in this opportunity, I would like also to inform you our keynotes speakers, Dr. Finn, and also all of our participants. Currently, our research organization for electronics and informatics, we just released one programs regarding collaborations. This is not collaboration platform, but by this research programs, we can make collaboration, especially on big data. The theme of this research program is high performance computing, artificial intelligence, especially for big data, large language model that we can utilize our SPC infrastructure. So I would like to invite you all for possible have some proposal to submit by this kind of scheme. This is not only for BRIN researchers, but also we can have a collaboration with our partner from local and also overseas. With that, I'm pleased to officially open the webinar. Let us make the most of this opportunity to learn, share, and inspire each other in advancing the future of secure intelligence systems. Thank you, and I hope you enjoy this session. Wassalamualaikum warahmatullahi wabarakatuh.
We would like to express our gratitude to Mr. Budi for the opening remarks. Ladies and gentlemen, we would like to invite Mr. Budi Prawara, Chairman of Research Organization for Electronics and Informatics BRIN, to kindly present a token of appreciation to our honorable speaker, Mr. Kwan Fimbang. Maybe Mr. Esa, you can accompany Pak Budi.
Thank you very much. Yes.
Once again, please give them a warm round of applause. Ladies and gentlemen, before we start our main agenda, now we will be taking pictures together. For participants in the Zoom meeting, please activate your camera and video function. And I would like to invite the IT team to assist in taking a picture. And for anyone participant in this room, we can take a photo session together outside of this meeting room. Okay, thank you. Silakan Bapak Ibu, kita akan foto bersama di depan terlebih dahulu. Bapak Ibu yang ada di Zoom, mohon izin kita ambil foto bersama. Boleh dibuka kameranya. Ini di saya ada 3 slide ya Bapak Ibu.
Sekarang masuk. Oke, Bapak Ibu silakan buka fitur kameranya. Mau 3, 2, 1 klik. 1, 2, 3 klik. Berapa slide? Sekali lagi, once again. 3, 2, 1 klik. Oke. Terima kasih Bapak Ibu.
Makasih Bapak. Ladies and gentlemen, we are now in our main agenda. But before that, I would like to remind all participants about the discussion session guide. Participants may ask questions using the raise hand feature, and question can also submitted via Zoom chat or box or the YouTube box, chat box. Oh, okay. It's okay. Moderator will select or invite the participants' question to be addressed. Ladies and gentlemen, I believe today is going to be a fruitful day because we will have Mr. Quang Vinh Dang from British University, Vietnam as the speakers. And for the presentation and discussion session, will be presided over by Mr. Wawan Hendriawanur as the moderator. But before that, I would like to read his brief biography. Aduh, aku nggak baca sama sekali. Pak Wawannya? Kok hilang? Oh ini dia. Oke. Iya boleh Pak. Mr. Wawan Hendriawanur is a researcher from Research Center for Data Information Science BRIN. He graduated his bachelor degree in mathematics from University of Pajajaran and master degree in informatics and engineering from Bandung Technology Institute. And for Pak Wawan, the time is now yours.
Bismillahirrahmanirrahim. Thank you, Ms. Kristanti. Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. My name is Wawan Hendriawanur, and I will be the moderator for today's webinar. Today's topic is knowledge graph and large language model for intrusion detection. It is my honor to welcome all of you to this event. Allow me to extend my respect and appreciation to Dr. Budi Prawara, Distinguished Chairman of Research Organization, Electronic and Informatics, Dr. Esa Pratasa, Distinguished Head of Research Center for Data and Information Sciences, our Honorable Speaker, Dr. Quang Vinh Dang, from the British University, Vietnam. Welcome to Bandung, Dr. Vinh. And of course, all the esteemed participation in this person and for Zoom and on YouTube live stream. Thank you for present and active participation in this event. Ladies and gentlemen, allow me to introduce the honorable speaker, Dr. Quang Vinh Dang. Dr. Quang Vinh Dang began his academic journey by earning bachelor degree in computer science from Vietnam National University and with master's degree in computer science in Seri University. And in parallel, he also bachelor degree in law from Hanoi University. And he pursued the postmaster degree in software technology at Eindhoven University of Technology, Netherlands. And Dr. Vinh completed his PhD in computer science in University de Lorraine, France. And in recent day, he completed the master in financial engineering at World Quant University. And through his career, Dr. Vinh has had several important positions as a lead AI researcher at Times Vietnam, as a lead AI project in banking and multi-agent system. And he also lectured in British University of Vietnam. He conducted the research in NLP and AI for finance and law. And also, previously, he is head of data at Fayette and VAC. And also, he held as manager and lead data scientist. And also, he is a postdoctoral researcher and engineering a specialization in computer security and cyber security and embedded system. We are honored to have Dr. Pin here to share his knowledge to us. Before we begin the session, I will explain the session for this webinar. Firstly, the presentation from the honorable speaker, and next the discussion session, and last the conclusion and closing remark. And this time is to the speaker or honorable Dr. Pin. Please, you have 2 hours for your presentation.
Yeah, thank you very much, Wawan. Let me share my screen. Okay, everything works well. Okay. Hello, everyone. It's my pleasure to see some new face. Okay. Anyway, let me make it like that. I know that it's a bit long, but today Lindum asked me to prepare for 3-hour session. I know that 3 hours is very long. I mean, I have been teaching for several years, maybe not as long as you guys, but as many of you know, I know that at the end of the session, many people will be sleepy, right? Okay, so I will try to make them make a bit informal. I mean, treating discussion as an informal discussion, right? Sharing discussion rather than a formal one. Okay, so I will move a bit because probably I don't want a lot during the day we have. Okay, but feel free. Sometimes you want. Keep doing whatever you are doing. Don't be like my student. Every time I work there, I just see the bright screen, right? They just have happened. I just see the bright screen. Don't be worried like that, okay? Okay, so let's and also this is also my presentation to many people today because it's a bit surprising. You're listening my present. Because as said, based on my own experience, the number of participants usually increases over time. It's the very first time I see that the number of participants is increased absolutely well. Okay, so anyway, today I will speak a bit about knowledge graph and LLM for intrusive replacement. Okay, I have been working with knowledge graph and also for intrusive detection for several years. So you will see some reference in fact come from my own. Oh, sorry, come from my own.
Hello. Oh.
Okay, someone will hear, yeah. Okay. And so you will see some reference come from my own publication, but it doesn't mean that it's the best one. In fact, it's by design. But anyways, just so that I know a little bit about what I'm doing. Okay. So the background is this. The British University of campus, and also we have the global BRIN. Yes. This is 1 minute commercial about UB. Okay. Because we have to say that we started 2009, and we want to be the gateway of holistic education. So each the student they want to take the holistic education, but finding out they don't want to go to UK or Scotland. So for instance, yesterday we told me that as a monastic campus, right? So you can be the campus of all the district universities in Vietnam. That's right. So here's the main room. It's a whole line. We have the school of communication engineering school and school of communication, and here is the new campus. It's pretty cool. Located in Hanoi. It's a university. So of course, because of the native university, right? So everything will be covered with degrees. Hopefully, we set on the country. But you have all the food in Vietnam. In Vietnamese. Okay. Okay. Now. Okay. I would say today, of course, I mean, we will have to say communication, but probably it's so clear, right? Today, I know we all know the competency of cybersecurity and the course you have to are not very installed or something. We have some number from staff. To be honest, I never believe in this number, but anyway, let's say that it's a new number. Okay? You will see some kind of market size, cybersecurity, or the market value, and this number cannot be verified. Let's say that. But anyway, it is to say that and we will know the cost value of the input cybersecurity. Okay? So, cybersecurity means everything, right? I mean, from the password of the file, etc. So, today we focus on only one thing, which is the intrusion detection. So, first of all, what is intrusion? Intrusion intrusion is basically everything that is kind of illegal or malicious coming from outside of the network doesn't make sense. Okay? So, I mean, if you have something already inside from the system like through that or virus, it's not an issue of intrusion. The problem is you cannot do anything, right? It's for the virus protection or detection or something. When we talk about intrusion, it's something coming from the outside of the network. Okay? So, because it's dangerous, so it's important to study. Right? So, why? The next question is why we should care about that. Similar to the presentation I delivered yesterday inside a smaller group, the attacking methods is already similar to our defensive methods. So we have a new way to attack the system, and there is no ideas. To be honest, I mean, no one really can define what happens in me. I mean, for the research alliance, I would say so. I would say, no, I don't think it. Okay. I mean, for the research alliance, maybe someone can claim that GNN is already international. It's something published 5 years ago already out there. But more or less, in industry, we can say the traditional ideas are moving ideas. So, for instance, you have the institutional idea in the list, right? Keep the idea in the list. So, we consider that as an intrusion. Not to be for the two audience, where is the voice audio recorder? This one. Okay. Okay. So I would like to say. So anyway, the traditional ideas, but not so traditional. Today, in most of the industrial system, if you ever have to conflict the router at home, you will see, I mean, basically they allow you to set up a lot of rules. Right? If L, that's all. And of course, I mean, from the computer science point of view, we all know that, I mean, if L doesn't work, right? Well, it didn't work, but I mean, of course, I mean, every time you have a new attack, you have to redefine the whole if L rule. And so it's quite easy. In fact, I mean, I would say 99% of the time, if you have to define, I mean, multiple if L rule, they will conflict to each other. The first rule will conflict with the 10 rule, right? Okay, so what we need is, let's say context our detection. That's why, I mean, we need to consider we should how to say, develop the new ideas. So, even, I mean, for the current IDS stand for intrusion detection system, and even for the current IDS, you see in the Cisco or Juniper system, most of them will use the static signature. And static signature basically is an interval. Okay, so you just map the static signature with the incoming flow from the internet, and if the answer is yes, you just say yeah, we block it. Okay, so we all know we have to say. I mean, of course, I mean it's pretty outdated. Right? I mean, the techniques seem to be in 19 something, right? It's not 2025. So I mean, any idea that I mean is still being used? I mean, machine learning is there for. I mean, every people talk about deep learning in more than 10 years, right? Everyone talk about deep learning and big data, AI, etc. Everyone talk about that. Right? From the media to Facebook to TikTok, everyone says that in this time of AI, we have to know AI is giving us. But everyone talk about that. People think that is something 50 years ago. But in fact, I mean, in practice, I mean, we've been using that. I mean, any idea why? Just, I mean, just some what method, right? It's not to test journalists, just to make sure that I mean, you don't sleep. Any guess? And by the way, don't ask ChatGPT, right? I mean, try to think first. Or Cloudy was in my mind. Okay. So anyway, the idea is, I mean, similar to what I shared in the yesterday presentation. Today, I mean, how many packets are sent every second over the internet? No one really knows. It's just a huge number. We cannot stop all of them running them through that AI system or machine learning system to check, right? I mean, it will slow down the entire internet, and no one can deal with that. So, but I mean, static signature is crazy fast, right? You can even do that by hardware. Right? I mean, you just have the IP package, you go to that, you run some, I mean, pattern matching, or you run through some variable expression there, and you can even run that with the hardware. The second thing is, that's why I said that we need to have the explainable, because if something is wrong, you can track why it's wrong. You can check what exactly is wrong. Just misclassify the package, and you can just modify. You can just do the debug and modify the email piece of code. But now I assume that people here are more or less familiar with, let's say, a machine learning technique like, let's say, classification technique like the XGBoost, or I mean, deep learning technique. But even let's talk with XGBoost. And I believe that I will assume that more or less people are familiar with, I mean, the idea of confusion matrix, for instance, right? You have the false positive, you have the false negative, something like that, okay? False, well, anyway, false positive means that, I mean, something which is actually negative, right? That we classify them as a positive. Right, and let's say you have something wrong like that, and how can you modify? How can you improve for the next time? For XGBoost. So now that's nowhere, right? The only thing you can do is we add that as a training data, we put that with the training data, we retrain the XGBoost, and we hope that next time it will not be wrong again. Right, there's no way you can make sure that it will not be wrong again, right? But we will think a bit about XGBoost. And somehow it is not acceptable in industry, right? The first time we make something wrong, it's okay. But the second time, and after that, the customer come in and you say that, yeah, we will try, we hope that at the next time, there's no problem, but I mean, we cannot promise, right? And no one can really have to deal with this kind of situation, okay? And of course, I mean, we don't have the semantic context, right? Similar to an example I told yesterday. Sorry, I mentioned yesterday quite a lot. Just for instance, let's talk about the financial transaction, right? If you send, I mean, 1,000 rupees to another person, there's nothing wrong. But if you send 1,000 rupees but million of times in 1 minute to the same person, it's million back perfectly. You are doing some kind of fraud. So what, I mean, in order to understand that, we need to understand the context of the transaction. But if we only think of the isolated event, right? I mean, we never can be able to capture the context. Okay. So that's I mean, for intrusion detection, I would say, okay. In the database, what are some database for intrusion detection? I will present later on. I mean, it's easy to read the performance to 100%. Whatever the metric you like. Accuracy, F1, AUC, PR, AUC, etc. However, one of the problems we do have today is the performance decrease quite significantly when you train the model in one data set and move to another data set. So overfitting is really the big problem. And of course, if we cannot understand overfitting, right, it's basically, I mean, all the model is useless, right? Yeah, okay. So, we already said, I mean, we need context, right? So, yeah, how can we add context? Is one way is we can treat. Let me. Okay. So, I mean, to have when we have the intrusion data set, right? It's one of the popular one. I would say there are several intrusion data sets. I mean, available on the internet. I would say one of the very first of them is MSL 99. As a name suggested and released by MSL in the KDB conference in 1999, so 26 years ago, but still one of them, one of the popular one. And for instance, the recent one is the CICIDF 2018. You can do the Google to see them and how that look like. More or less, you can see that here the list of pictures. Okay? You can only then to look the the second one is the active in the forward direction. So more or less they are all related to the internet connection, right? And the idea is for the intrusion for all kind of intrusion data set like that, you have a very big Excel file logic. It's not a file application, okay? But more, it's around 100 color and few million rows. But more or less you have a very big Excel file. That's all. And each one row in the Excel file is being traffic flow, right? And at the end of the day, you have to decide whether or not the traffic flow is benign or malicious. Okay, so you see that is basically a very classical standard tabular data that we can use by any classification algorithm from logistic regression to whatever, right? But now we are talking about adding context. We are talking about we need to understand the relationship between instance, right? We cannot only understand only one row, right? And I mean, make the classification. We have to understand the row in the context of its own. So how can we do that? Okay. So the very first approach, well, we can do that. Not multiple approach, but just one approach in the work 2022, like that, okay, is, by the way, let me ask you another question, right? Given a very big cell like that, okay, and here is the result data in the context, okay, and you have million or billion of rows. From that, how can you define the context? Because I mean, originally speaking, there's no context. Basically, you can pass this Excel file to let's say EasyBoost, right? And of course, you have to load it in pandas, and after that, I mean, feed that to EasyBoost. But I mean, when you go to the EasyBoost, basically EasyBoost will treat its flow instant independently. It doesn't care what happened before. It doesn't care what happened after. Right? It's only care about this instant. Just like you want to classify if a person coming is fraud or not, right? You only care about this guy, this time. You don't care, I mean, what he did before, what will he do after, right? So how can we inject or embed context to this kind of file? Is one way is we have the entity, okay? So what is the entity we can form from the internet traffic data like that? Yes, it's pretty clear, right? I'm not sure it's pretty clear, but I mean, usually the internet, the whole internet we are using now is represented as a graph or as a network, right? And what is the node in this network? What is the vertex of the network? Host, right? So basically, after you have the traffic flow, you can form the network. I mean, computer A send information to computer B send information to computer C, and C send to D, etc. So more or less you form a kind of network, right? And after that you have the graph that create the multi-step events, right? And after that you can perform some kind of reasoning. Reasoning here, let's understand reasoning here in terms of modeling. I mean, you can perform some kind of machine learning model over the graph to figure out what is happening. Okay, that's the idea. So the idea is instead of consider traffic flow one by one, now you also to form the graph to say that hey, from this traffic flow I see that A send something to B. From this traffic flow I see that B is sending something to C. After that you have the use graph to see how the information is transferred to the network, right? Okay. So for instance, in the paper, what we do is they create a knowledge graph that basically states that who appear with. Okay, because for instance you have videos, right? And I mean when you have videos, you see some traffic come from the server in the computer ABC. You know that A is malicious, so probably B will be a malicious as well. Maybe they are just by coincidence. They are trying to access the server during the video's time, right? But of course, I mean we can do the reasoning like that. Okay. So the idea, of course, I mean probably we don't have enough time to go through into the detail. But the idea is basically we form the noise graph from the they use MSLPD, as I said, one of the first intrusion data set published in the internet. Okay, and after we have the noise graph, statistic, right? They feed that to the is common one, right? So with attention. And you hope that I mean you can detect the you can detect the how to say, you can detect the malicious traffic flow. Okay. So of course, here's the result, copy from the paper, and as usual, the result presented in the paper always said that, there's a method is the best one. Okay. But the main idea here is trying to inject or embed the context around the traffic flow, right? Rather than only consider this traffic flow. Just like, I don't know if you have worked with, for instance, image classification. Okay, and usually for image classification, we do classify image independently. You have an image coming in, you say that is dog or cat, right? You don't really care what happened before, what happened after, right? You only do the classification independently, and there's no contact with it. So, but more or less, in the intrusion detection, the key message is we can do we can embed the context into the intrusion and improve the performance by lot. Okay. Now, the next one is understanding for security. So, we are talking about the level. What the problem is, the current is lacking the context. So, how can we do that and embed the context on this slide? The second one is explain label. Explain label means that, what does it mean? Explain label means that, if some traffic flow is classified as deny or malicious, right? You just accept that, and we don't know why. Similarly, tomorrow you apply for the bank credit card, or apply for a loan with the bank, or you apply for a new, sorry, it should not be here, right? But you apply for organization or company, and they rejected you. They just say, yeah, we are sorry, we cannot accept the application. You don't know why. That happened, what's wrong? We have no idea, right? Similarly, explainability is somehow missing in the current ideas. So of course, with the AI, we can somehow bring the explainability to the ideas, and it's called language understand possibility. What does it mean is we can use LLM to analyze the log, right? And how to say, usually we think that the log is kind of very structured, right? But if you are a programmer, you know that the log in practice is really messy. A lot of developers, just log the log info, and after that they forgot, and they keep that, inside the production code, right? So sometimes the log is written in different language, right? Sometimes the log is just, in fact, they should use debugger, but the programmer doesn't use debugger, so they use a logger as a debugger, and after that they forgot. So inside the log of the system, you see all kind of messaging, right? Sometimes it says hello, hey, I'm here. Sometimes it's really very complicated information. And before the time of LLM, of course, it's very difficult to understand all of them. You have to really read through them one by one. Really hope that you can understand them manually, right? Of course, today, luckily, we have LLM. So the idea is we can use LLM-based model, or LLM model as it basically, to analyze the log. And after that, when you classify a traffic flow as a malicious, as an intrusion or not, you can also generate the explanation why. Or you can create an AI to work as a kind of system to say that, hey, more or less, I have the feeling, I have the belief that this traffic flow is my research, but you probably want to know it. Okay, so it's a benefit of LLM for security. Okay, so when we talk about knowledge graph, it is, well, basically the slide I copied from this slide for people who did not attend yesterday's webinar or seminar. What is knowledge graph? We already mentioned knowledge graph. We said that we can use knowledge graph to embed the context. But what is a knowledge graph at the end of the day? Knowledge graph, as the name suggested, is a graph with the knowledge inside. Okay, so here is a knowledge graph. Okay, so it has the entity, for instance, the Mona Lisa, Leonardo da Vinci, released to the Eiffel Tower, roof, whatever. Okay, so knowledge graph will embed and express the information and relationship between the entity in a graph. Okay, so of course, I mean in the intrusion detection scenario context, you can understand that the entity here are not Leonardo da Vinci, are not Mona Lisa, but they are host, right? And the information they are sharing here is not Leonardo painted Mona Lisa, but I mean host with the IP host A, right, is sending, I mean, how many traffic flow, how many bytes to host B sending, I mean, how many bytes to host C, etc., etc. Okay, and the knowledge graph is basically a triple like that, right, with the subject, relation, and object. Okay, and very simple like that. Okay, so even before the LLM, knowledge graph already supports semantic query. For instance, you can ask what the example I gave yesterday. What is the relationship between Leonardo da Vinci and Paris? Right, and without the knowledge graph, if we are looking for, let's say, text embedding, like word to word, right? Anyway, I mean, what is the idea of word embedding or text embedding? What is the idea of traditional text embedding like word to word? If you remember, the idea is basically if two words, I mean, occur, or I mean, they happen to be together a lot of time, they're more or less similar, right? But I mean, if you use this kind of idea for querying, you see that Leonardo da Vinci and Paris has no relation. Right? Da Vinci never been in Paris. If I remember correctly, so I have to ask ChatGPT. Okay. But I mean, without the knowledge graph, I mean, we just check on the text with the Leonardo da Vinci, and we realize that, I mean, yeah, I mean, he has no relationship with Paris. However, with knowledge graph, even the relationship is not so clear. We realize that, hey, no, more or less, I mean, he has some relationship with Paris. Okay, so even before the time of LLM, knowledge graph is already have a solution to support the semantic query and inference. Okay, and in order to support the knowledge graph, we need something called ontology. Okay, so let me try to explain ontology one more time. Knowledge graph is something like that, but you have to define what is the class, or what is the class of the entity, or what is the class of the entity, or what is the type of entity. For instance, Leonardo da Vinci, in this case, he should be a painter, right? And Mona Lisa should be a painting. Leonardo da Vinci, more or less, probably he cannot paint a person. He can only paint a painting. Okay? And the idea is, if we define the knowledge graph by our own, probably, I mean, we'll come up with different class and definition. For instance, someone just define release date, Harry, whatever, as a person. Okay? Someone want to define them as man and woman. Someone not man and woman, but male and female. Okay? And after a while, you have different knowledge graph. They are basically describe the same thing, but the knowledge graph are completely different. So we cannot map them, we cannot merge them, we cannot process them. So in order to deal with that, we have something called ontology. Ontology is something we predefine. We said that, hey, if we are talking about human resources, we are talking about BRIN, here is only few classes we can define. Research, I don't know, lecturer, do you have any? Yeah, something, you have the human resource, especially, you have security man, etc. But I mean, probably you don't have present. Do you have present? Anyway, whatever. I hope you got the idea. So you predefine that. Here is the class you can use to define the activity. You cannot use anything else. Here is a relationship, right? So, for instance, between the, I guess it's true, right? Between the persons, the position in BRIN, there's no relationship like old, right? We don't have slavery, something like that. Okay? So I mean, we cannot define something else. We only use the class. We only use the connection predefined in the ontology. Okay? That's the idea of ontology. Ontology at the end of the day to make sure that everyone is the center to talk about same thing. As I said, it's okay. So for security, so I mean from that we can expect that we should have only one ontology, right? Because at the end of the day, you have 10 ontologies and they have the same problem, right? Now I mean, BRIN is one ontology to define, and after that, I don't know if another university will use different ontology. Right, and after that, I mean, we cannot merge them. So, here they code article, here in BRIN we code paper. Even at the end of the day, they are the same. I mean, from the computer point of view, they are not the same, right? So you cannot query, you cannot say anything, right? For instance, you want to ask how many papers we have as a collaboration between BRIN and this university. But because in BRIN we use the term paper, and in they are the one they use the term article, right? So I mean all the query, okay? So the ontology, anyway, so I mean based on that, we can expect that the ontology is, we should have only one ontology, right? But of course, as usual, I mean life is never easy like that. Even for the security, cyber security, we have several ontologies. Just like I don't know what is the I don't know. I mean, nothing really ringing my bell right now. But I mean, for instance, I mean, even on the internet, right? I mean, sometimes it's expect that's only one standard, right? But turn out that I mean, different people use different standard. Apple, I mean, doesn't want to use Microsoft. Microsoft doesn't want to use Apple, so it's a different standard. So no one really can talk to each other. Okay. What ontology we do have in cybersecurity is we have several of them. I'm not quite sure if the complete list. For instance, we have the first thing called stick. We have the mid-range, not sure how to pronounce it. We have UCO, Unified Cybersecurity Ontology. Okay, and I mean, let's take a look. What do we have in the ontology? For instance, here is I think I already said that is the right. Here is a piece of the stick version 2.1 ontology. Then that you have what kind of object you can have. You can have attack pattern, campaign, course of action, grouping, identity, indicator, and more. So I mean, can you have the object like person in stick? They said no. Cannot. Reality, right? Can you have the researcher in stick? No, you cannot, right? So tomorrow, if you let's say you choose stick as the ontology, you want to define the new knowledge graph for the cybersecurity for your own data set or for own all the attack you have at BRIN, you have to choose one depending around 80 class. Okay, you cannot define your own. You cannot define new class for research or whatever. Okay. So here is there's another paper that you can read, and also they make a review of the security ontology. They also mention something like Stucco, UCO, etc. But more, and also for specific scenario ontology, UCO or STIC are kind of generic ontology for cybersecurity. But sometimes you don't really care, right? For instance, you only want ontology for DDoS. You have to either adapt an ontology, or you have to create your own ontology. Okay, but just remember, just to clarify, ontology is something definition. Okay, to say that here are the object, here the entity type, you can have nothing else. Okay. So and from the ontology, of course, we can form the graph. I don't know, probably it's not readable. Let me try to see. Okay, so here is, now we have ontology. We need to create the knowledge graph. Okay, and here is an example of a knowledge graph created by STIC ontology. Okay, so for instance, we have indicator, malware, and campaign. Indicator and campaign are the, and also malware. They are the entity defined by STIC. Okay, so you see here the relationship between them. I'm not quite sure if I can see, but for instance, you see something like CVE 2012-0158. CVE is a database of the vulnerability. Okay, so from that we can understand that, hey, this kind of attack right related to this vulnerability. Okay, so the CVE is a public database. They are updated. I don't know. Sometimes they are updated quite frequently. Every time they found a new vulnerability, for instance, in Chrome, in Microsoft Windows, in Mac OS, whatever, they will add the new item. If they consider that it's a new vulnerability, they will add the new item to CVE dataset. But now you have a new attack. CVE is a vulnerability. Something is wrong in your system. But we have an attack, right? And how can we know that what attack related to what? What vulnerability? We need the knowledge graph defined in the ontology of STIC, like that. Okay? So I hope this gives us a bit more clear of what is a knowledge graph, what is ontology in the security using STIC. And you have another thing with Mitre or UCL. Okay? More or less, I mean, they are just different ontology. Now the question you might ask is, I mean, what ontology you should use if tomorrow you want to do something with cybersecurity and knowledge graph? The answer is, yeah, just like, I mean, what kind of phone you like? If you like Android, I mean, just buy one. If you like iPhone, just buy one. There's nothing better than the other. Okay, it's just a different ontology, and more or less, I mean, they all exist. Okay. Okay. Now, for us, I think it's a bit of overview, right, of knowledge graph and how can we use that in the cybersecurity. Okay. Now, for us, not quite sure if it's for us, but at least, I mean, from many people in Muslim community, the first thing we need is a data set, right? And I mean, to have the data set is not an easy part, right? Okay. So the very first thing we need is the data set, and luckily for the data source for knowledge graph, we have several open data sets. For instance, the data sources for knowledge graph you want to create, as I already mentioned, we have the CIC. CIC stands for Canadian Institute of Cybersecurity, and they maintain, I would say, more than 100 open source
dataset for cybersecurity and intrusion detection. The website is UNB, unb.ca/CIC, okay? Or you just search for the CIC dataset or Canadian Institute of Cybersecurity dataset, okay? And you have quite a lot of open source dataset, and this is pretty good sources for creating the knowledge graph and I mean verify or evaluate the algorithm. The good point is because these datasets are popular, it's also a bit easier to compare your algorithm with, I mean, published paper. Okay? We already go through that, right? So, I mean, if you download CIC IDS 2018, you will have a basically you have the very big CSV file. No, in 2018, you have several big CSV files, but more or less they are just CSV, right? That's an Excel file, that's all. Yeah, few 100 million rows, around 100 columns. But more or less, you have a lot of Excel file, CSV file, and after that, you do whatever you want. For instance, you can form the knowledge graph using stick, and after that, I mean, integrate that with your algorithm and to see if it's improved or not, or I don't know. It's really the problem we have to answer, right? Also, if you don't want to create your own knowledge graph, because today in order to create the knowledge graph, we will go through that, right? But I mean, in order to create the knowledge graph, it consumes quite a lot of computational power, and practically in 2025, probably the most common way to create a knowledge graph is calling an LLM, for instance, OpenAI API, so you have to pay for the API cost and something. So if you just want to use a knowledge, and by the way, when you create a knowledge graph, it's a probabilistic process, right? So maybe, I mean, your knowledge graph created from same data set is different from my knowledge graph. Okay, so if you want to just have a knowledge graph to evaluate, to test, to make sure that they are the same, we have several open source ready to use knowledge graph. Here's the link. And if you really want to know the link, we have the paper here, published in 2023, 2 years ago, more or less, but we already have several knowledge graph for cybersecurity. Okay, so you can try to read the link over the research graph. Okay. Okay, so now let's try to finish that before we have the short break. Also, we have the short break because it's pretty long. Yeah. What do you mean? Can we break the moderator? I don't know. Why should I ask you? I should ask. Okay. Okay. So anyway, the agenda is we already talked about the knowledge graph, a bit of cybersecurity. Now the problem is, this knowledge graph is just a graph. I mean, we are computer science guys, right? I mean, we all have the cost by graph theory or graph algorithm. We all know about that, DMS, right? A-star, finding source, diagram. I mean, this something 2 years ago, anything new. I mean, at the end of the day, how can we actually use knowledge graph for cybersecurity, right? I will go through, let's say, around 10 use case of the knowledge graph in the cybersecurity. After that, I mean, we go through some paper, go into the detail, say that actually, how can we actually use the knowledge graph for cybersecurity? And after that is let's say how much time we have left. Okay, so 5 minutes, right? Let's go back at 10:15. Thank you very much.
We have a break for 5 minutes.
Thank you, Wawan.
There is some coffee and snack in the outside. Please.
Okay, any questions so far? No? Yeah, just to make sure that at least some people are listening. Probably we should we can use the movies like okay. So after this, I mean, so we can move. It's very short and moving back and pretty simple. But let's say the idea you have the text part, you have the PDF file, but you just have the text part, right? And how can you form the knowledge graph from that? Okay, the main point is you have to be able to wait for all the text. Okay, but the idea is we already talked about knowledge graph. How can we use that? But at the end of the day, how can we create one, right? Form our data. Okay.
We have long time, so it's really, we have long time until it's one.
Okay, cool. The audio is here.
Yes, you can move.
Yeah.
You can participants in here have question. Please raise your hand and directly.
Sure. But usually we need someone who asks first. Okay, so let's go back. Okay, any questions so far? No, even the synthetic one. No. Okay. Anyway, we already have we already talked about the knowledge graph, right? I mean, more or less, I hope you know what knowledge graph is and what knowledge graph in cybersecurity is. Yes, you can raise one mistake, okay? And because today is a bit more public, so I mean, I don't really so I mean, but to be honest, I mean, it's really easy to create that with Spark. To be honest, I never know what to know Spark or Cypher. This is language to work with the knowledge graph, right? And we have like coding. But more or less, now let's go into the application of cybersecurity, the knowledge graph with cybersecurity. Okay. So we go quickly through that. I mean, we have the ingestion pipeline. Basically, how can we map? How can we add the graph, add the knowledge graph into the cybersecurity defense pipeline? We have several names here. As such, I mean, we have several libraries. To be honest, most of the time we work with Python. I'm not quite sure for other languages. But you have Seri, you have Nebula graph, etc. You have also PRSDI, so very up to you. And we don't really go into implementation today, right? But if you are pretty new with knowledge graph, I think you can start with Seri. It's pretty easy to work with. Okay. So the query language of for the knowledge graph, after you have the knowledge graph. The query language, yes, the name suggested is not structured query language, but it's a graph query language, but more or less they are query language and they are similar, right? You see that for instance, you want to look for something, you will have select something from something group by order by limit, right? More or less it's kind of simple, right? But then the all the query language that have the same, right? So we don't go into the detail of that, okay? And also we have the reasoning engine. Reasoning engine is basically when you have the query language, but similar to SQL engine, we need to convert the query into actual by code, running code, right? We also have the reasoning engine, but also we don't go to that. Okay. So, for instance, how can we have the how can we actually perform cybersecurity on knowledge graph, for instance? Let's say you have the knowledge graph, who sent data to who. Okay? And now one of the first technique, hope that I mean give you the idea, is the attack path, what we call attack path analysis. And one of the paper we can read is the paper here published in 2020. Okay. So what is the idea? We model the risk ability via vulnerability. What does it mean? Here you have, let's say, millions of computer user network. How can you know that from the computer A in Indonesia? I can access some computer F in the United States. It's not only that we have the connection. Of course, today everyone has a connection to everyone. We have internet, right? However, we model the risk ability via vulnerability. For instance, we have the vulnerability between A to B. So A can access to B. And between B and C, we have another vulnerability. So from B, we can jump to C. And after from C, we can see that another vulnerability, we can from C jump to F. So we can model the attack path like that. Okay? And from that, we can say, hey, if I am staying in the computer A in Indonesia, how many computer internet network I can have access to? And basically, it's a very graph, very focused graph. Yeah. And after that, of course, all the attack is not free. Right? So if I have two options, either I can jump immediately to another computer in Indonesia, or I have to access to another computer in the United States. Of course, in terms of cost of money, right, the second option is more expensive. At the end of the day, I mean, I have to pay, I expose more risk, right? So, I mean, if there's the same right, I want to control, I want to attack the computer nearby, right? Rather than doing something to something, let us say, right? Okay? So, we can compute the shortest attacker path to see what kind of priority the attacker might want. Okay? So, here's the idea. I'm not sure if it's readable. So basically, you want to, the idea is we inform the attack graph model, okay, and we set up the minimum path to the road, and after that you exploit the success probability of the attacker, okay. So after that, you can calculate the probability of the attack success from a node to another node, right? Okay. So to say that, at the end of the day, and let's say if I'm the attacker, I stay in the computer A, what is the success probability if I attack another computer? Okay. Because the vulnerability is just a possibility. It's not 100% for sure. For instance, if you have the outage Chrome, right? You have the vulnerability. You did not update the Chrome yet, you have the vulnerability. But it doesn't mean that it will be attacked. Or even if you're attacked, it doesn't mean that it will be destroyed. It's just a possibility. Right? And if I'm an attacker, because I try to attack the easiest guy, right? Maybe you have added the Chrome, you are in the corporate network, you already have the firewall, you already have other technique to protect you, right? So even we have the same vulnerability, we have the different success probability. Right? So at the end of the day, we can calculate the success probability when we attack it of the node in the network. Okay? So also we can model the botnet topology using the graph, and using the graph algorithm we can also use the graph metric to review the bot behavior to basically detect the bots in the network. Okay, we have some case study here. I will skip them more or less. But we have case study from Tentang and CrowdStrike. So basically, all of them are using graph knowledge graph analysis to perform to improve the cybersecurity. Okay, we have knowledge cyber threat intelligence knowledge graph survey inside, but more or less they say the same thing. People are using more and more LLM and knowledge graph to perform the analysis. Of course, it cannot be comparable with the traditional IDS using the static signature. Because at the end of the day, it's very slow, but more or less, we are doing research on that. Okay, so now, if you are kind of curious, how can we use knowledge graph? Even, in a very simple case, right, for cybersecurity, that's an example. Now let's go through a bit different application when we use knowledge graph. Okay, so let's say the very first use case is called situation awareness and security assessment. What does it mean? I don't know. Anyone here working as a cybersecurity specialist, IT team or something? No. But I don't know if you, BRIN do have security audit. Maybe. Security audit, so we basically someone will go and check it and your security system is good or not, right? If you want to apply for a very big project of NASA or FBI, of course, they have to audit it to make sure that they don't, if you don't leak all the information to NASA, right? Or by website, right? So, of course, how can people do the security audit? Oh, but maybe at least internally, we want to do security audit, right? We want to make sure that nothing wrong with our system. And we never know, right? So how can we perform the security assessment or situation awareness or necessary security assessment? Of course, we already have expert, some security guy come in and check, hey, everyone install this, install that, in all the port, and you have the protection. Of course, we have the human expert, right? But human expert, I mean, sometimes they miss something. And for security, you miss only one port while you are done, right? You have to cover, you have to protect everything. So how do we handle the victory? Measure our security power. Okay, and I hope the slide is a bit clear. Okay. So let's say we have generally the security audit is mostly data audit. What's the most important thing today is data. Let's say let's forget that we don't want to have the data. Right. Okay. So how can we do that from the knowledge graph point of view? Okay, so what are the input? For example, you have the CMDB. CMDB stands for configuration management database. Yeah, configuration management something. So first of all, you list down all the data assets you have, for instance, the salary information, some research, some patent, some whatever, right? You don't want to review to the work. You have the network config, right? Who connect to whom the network topology of the whole grid. Okay, we have the vulnerability and what kind of fix you apply. For instance, I mean, if you upgrade to, I mean, newest scroll or I still running Windows 7 that are no longer supported, whatever, right? We have the IDS log, and we have some external CTI report, and CTI report is a PDF report released by the cybersecurity company. Okay. And now, how can we do that? Okay, is we will create a knowledge graph of the data assets of our organization. Okay, what is it? Some entity. Some entity, for instance, here we have the salary database. Salary database is asset by human resource. Human resource have any vulnerability? Yes, because they still running Windows 7. I don't know. I mean, maybe, right? Or they didn't update, or they never update, or they don't care or whatever, right? And they access to other service, right? And they have some trend, okay? Etc., etc. And here is another patient pattern, or maybe some research you don't want to review. Do you want to upload whatever you are writing in the PDF file? And it's another type access, right? Who can access to that one type service? But I mean, this file have access to Microsoft Azure because you are running for Analytics or Microsoft Azure, right? So after all, you have the knowledge graph of the data access and service and vulnerability and threat of everything in your organization. Hopefully, right? So after that, you can calculate. So after that, you can calculate the kind of risk score for each data asset. Okay, so you can, and risk score basically is the security audit, right? After that, you make a very long report. Hey, in BRIN, you have 10,000 data file, Excel file database, right? Some of them have the risk score is pretty low, pretty okay, some is very high, more or less like they already okay. Okay, and it is basically the security audit report, right? So for instance, what kind of triple we can have in the knowledge graph is you say that host exposed to the service, for instance, host of Linux exposed to, I don't know, Google Colab and Microsoft Azure and I don't know. And so, yeah, in certificate, right? Service has vulnerability, for instance, Google Colab has something wrong with data leakage, right? And vulnerability exploited by attacker. So, I mean, if you connect all of them, right, you see that, hey, Linux, even he looks pretty safe, right? But turn out that, I mean, he's being leaked by whatever. Okay, so, I mean, if you form the knowledge graph of that, you can have the security audit. And also after that, you have the exposure of, let's say, this computer, for instance, is the sum of everything, right? Maybe the risk via Google Colab is pretty small, but you also have the risk via other service you have access to, right? And everything can be done algorithmically. So after that, you have the risk score of everything, right? Rather than, I mean, you need to require human expert, and human expert is subjective, of course. I mean, they have a different idea. Who knows, right? Okay, so for instance, you have this kind of part, right? And it turns out that the VB01 is being reached. Even you say that, hey, we have the internal database. It has no internet access. How can it is leaked, right? But if you have the knowledge graph, you realize that, hey, even you have internal database, it's not so safe. Okay, so that's one of the very first. One of the ways to use knowledge graph for cybersecurity is to the security assessment. Okay. So also we have the report and use case from Neo4j in this website. In this URL, you can come and see how Neo4j also monitors the network. I mean, using the knowledge graph. Okay. Now, threat discovery. Always the big problem with cybersecurity, right? Or zero-day attack. What is a zero-day attack? Let's get your name. So the brand new attack never happened before. It's the first time they happen. They happen to work. Oh, this one follow me. Yeah. Okay. It's not a AI yet. It's not AI yet. Okay. Otherwise, it's quite scary, huh? Okay. So how can we use? Well, anyway, up to now, in last 40 years and up to now, zero-day attack is pretty easy. Because how can you stop the attack for the first time it happened? How can one treat it in security? Right? And I mean, let's say 20 years ago, what happened is you have a zero-day attack. After that, I mean, some computer will be destroyed. And after that, some expert from that country or that person, that country or Cisco, they will download, they will break the sample, they will do the reverse engineering. It's pretty fun process. I believe at some point, same removal is very right. They will create the sample of virtual computer, they download the driver, they do the reverse engineering, they try to analyze the attack, right? And after that, they create the static signature. And after that, they implement the static signature into the system. So next time it will be blocked. Right? It's a quite a long time, right? Really, we need to, I mean, really expert, and they only have to go day and night to do reverse engineering. And you can see by some blog posts when they tell the story of how they do reverse engineering of the virus or the attacker. It's pretty cool. However, of course, we hope that we can more or less do that automatically, right? So let's say we want to use knowledge graph to improve the threat discovery or zero-day attack or something. So what are the inputs? Okay, we have the sensor alert and audit log. It's just a log. We don't know if anything wrong with the log. It's just a log, right? And as said in the beginning, we can use LLM to process the log, but basically it's just a log. Okay. We have the system code trace. System code trace is for your information. System code log is also one of the very important resources to analyze or to detect if something is attacking the system. System code is system code. You know what system code is? Right? No? System code, every time you write a program in Java, in C, yeah, you have to make some code to the operating system, right? What's the form? What else? No, even lower than that. I mean, at the end of the day, your program will make the code to the operating system to create the new process, to reserve for the memory, etc., etc. So, for instance, probably one of the most system code we have is 6 integer, for instance. If you want to kill another process, for instance. Okay? So anyway, I mean, through the running of the program, you make a lot of code to the operating system. And I mean, of course, the virus or the attack or the intrusion usually they make a lot of, unusual system code. Because they want to read another data of another process, they want to override some, your own data, etc. Right? But of course, we don't really know the pattern, but we need to expect that, the attacking process will make a lot of unusual systems. Okay? We have some other information, and also we have the graph access, right? Here is the database, here is the Seri information, here is the personal information. The graph access we just waited in the previous step, right? And now, the very good thing is we can predict the future attack. How can we do? Even we don't know what kind of attack is, but we can somehow expect that you will be the victim. Even we don't know how. Any idea? Okay, so in Indonesia you have Facebook, right? Okay, you also use Facebook, right? Let me ask a question. Did you ever see Facebook suggest something to on the internet? Right? So that's here's some people you might know, right? Here's some event in my life. Here's something you want to reach you recommendation, right? And if you think a bit, basically the same idea applies. How can Facebook know that you have this item is probably the next item in line? The same algorithm will predict that this computer is probably the next item will be attacked. Okay? If you think a bit, right, here's an item, here's a person. We have billion person, we have billion item. And we predict that, hey, probably this item is the next item this person will have. Now we have several computers, we have several data assets, we have several items. And somehow we think that this computer is probably the next computer to be targeted by that item. So algorithm, right? So the algorithm is basically is called link prediction algorithm. Okay. So the link prediction algorithm is very classical, not classical, but more or less already being researched in the graph theory and social network analysis. But however, you can predict something like, hey, this asset, for instance, this database salary, the probability that this database may be compromised with this vulnerability is 90%. Okay? So probably this database will be attacked in the next time. Okay? So again, even we don't know. How can, right? Because we only expect that this is exploited by the vulnerability, but we don't know the attacker. But more or less we can expect that, I mean, this database will be the next thing. And what do we do in this case? Yeah, how can we prevent that? Yeah, that's I mean, that's what our powers of people. Okay, with one button right in front of the computer, so we stop all that. Okay. Okay, so is how can we use graph? Knowledge graph, right? To improve the zero-day prediction or zero-day attack prevention. Okay. How many use cases we have? No, only two. We have several one. Now we have attack happen, right? And sometimes in the guy here, yesterday there's a person here, right, who asked me that his credit card is stolen, right? Who?
Mr. Andre.
Yeah. And of course, I mean, sometimes you see that in recently my LinkedIn has been hacked. I mean, all the right information about. And okay, it happened. We have to accept. But the next question is, what happened? What did I do wrong? Or I mean, my credit card is stolen. Okay, it happened, right? But the next question is, what did I do wrong? Because most of the time, I just need to go to the normal. I never reveal my password, right? I mean, more or less, I mean, we are computer guy, right? I mean, I'm not so stupid enough. I'm not as stupid enough to reveal my password or I'm using any password. 1, 2, 3, 4, 5, 6, right? I mean, we never use that. We turn on everything. But somehow we like anything happen. Generally, what's going on? That probably, I mean, I asking the question why is one of the very important questions for human to understand rather than it happened. If we say it happened, yeah, we say yeah, it happened. That's all. This is not the research question, right? One of the research questions is always to ask what happened. So now we have to explain. Does the attack already happen? And we have to explain what really go wrong. Yeah. And again, of course, we are in the presentation of the noise graph, right? How can we do? So for instance, again, we have the host audit block, okay? We have the log of our host. We have the network flow metadata, similar to the CIC IDS. We have how many packets, how many flow we receive, what timestamp from what IP address, etc. Again, we have the asset node, right? The asset graph is the most important thing we have to create. And the output we might have is the causal event graph, actual attribution and consequent prediction. But let's say we can create the causal event graph to set up what link to the event that my information is stored. Okay? So for instance, we convert and how? We convert all the alert to the event node with timestamp, okay? And again, it's not an idea. I don't say it's the best one, but at least give you an idea how can you do that one. We say that in the delta T tab, event A and event B. It means that event A lead to event B, right? You click to that, it's straight one block. And after that, when the password is gone, more or less we can think that before we click with the link. You are not right. We never know, but at least I mean, this kind of easy way to move on, right? And after that, I mean, we sort everything by timeline, and we create the causal graph, and we have the LM to summarize the story for you. And for instance, you will have something like, hey, you can explain to the victim that, hey, because you have the phishing email, and you open the phishing email on the Outlook, and the Outlook, I mean, call the command prompt, right? And after that, you call the command download something, and you run that, and that's why you lose automatically, right? So next time, I mean, it's because you read a phishing email on Facebook. It's not because you are opening Facebook or you are whatever. It's at least you explain, I mean, what is going wrong, right? Okay. Oops, sorry. Okay. Now, the next thing is alert correlation. Is more or less when you have the attack, they never go along. They only go together. And when you have alert from different systems, right? Sometimes it's just a point alert. But sometimes you have a lot of alerts together, usually it's alert from the same attack, right? And how can we group them together? Okay. Okay, so let's go to how it works, right? We have alert to the noise graph, no? Okay, because alert is something we predefine, right? You cannot have the alert, I mean the new alert. Alert is only something we already know. So we have the alerts coming, we know where is the alert in the noise graph, okay? After that, we can build a similarity graph, and you run the label propagation algorithm. Okay, each of this step can be a research question, because how can you run the label propagation better? It's already a research question, right? And after that, you calculate the severity score of the cluster, and we always have that. We can always call LLM, OpenAI to explain the camera story, right? And after that, we can say, hey, the alerts this and this, right? Probably they are going together. Okay. So that's the idea of using noise graph for alert correlation. Now, for attack and defense strategies, okay? Are we going to finish? Yes, we are going to finish. Okay, now, attack and defense strategy. What does it mean? Yeah, similar to the previous question. Now, of course, I mean, I don't have money to pay. Basically, we cannot protect everything. We have to choose somewhere to attack, and we have to choose somewhere to protect. Because we have also the usability we protect everything. All the operations will be slowed down. Every time you do something, you have to do MFA, you have to re-enter the password, you have to do face recognition. Every time you just click the mouse, right? So basically, we have to choose the wise attack and defense strategy, right? And how can we do that with knowledge graph? Okay. So as usual, we have the vulnerability feeds. Okay. From the Seri, as I said, when the Seri is a vulnerability database, you can search that on the internet. We have the network topology as usual, right? Because we know our topology. Even it's not so easy because today we have laptop and people just move all around. But anyway, let's assume that you have the network topology. Okay. You have the music impact values. I think this doable, right? If some information is leaked, we can. For instance, I mean, if my salary is leaked, I mean, nobody can, because everyone knows that is low. However, if some other information is leaked, right? Yes, we have some, right? Okay, and with this input, we can have the rank output set. And how can it work, right? We can have the knowledge graph, diagnosis, vulnerability, exploit, and privilege. Okay, and we can perform random walk with restart it's random walk when we start is the idea of deep to walk, right? We start from the domain admin, from the admin computer, and we move around with the random walk to see, I mean, at the end of the day, what part or what node we are mostly to stay in at the end. Okay? We compute the path probability, say that, hey, probably with 70% from the domain admin, I stop at this computer. Okay? As we have the risk of the path, if we mean probability of the path multiplied with the CBS, with the business impact and with the severity score, okay? And always we have a display. So it means that, for instance, at the end, we can say, hey, this path, right? Okay, is a top vulnerability path. Okay, so probably you want to improve your security or whatever. Okay, on the other hand, you can use that as an attack strategy. You say, I don't know, to be honest, I'm not quite sure how can, but assume that the attacker have the network topology, right? And yeah, the attacker can see that, hey, this path is probably the most easy path, right, to attack. Okay? Not most easy path, the most impact path to attack. Right? Because I mean, they can attack, I mean, some computer, but it doesn't have any value. But of course, it's not always the case. Now, another problem, I think is also cool, is the malware analysis. Okay. What is mean that, I mean, okay, how can we detect malware from that? Have any idea? At least I mean, have the idea. How can we detect the malware? In yeah, memory device and something. Now let's say you have the capacity, right? You go back to 50 years ago, and you know that this time no one knows what malware is, right? I mean, we can make money by starting the malware detection from the past. But I mean, how? Let's say if we cannot bring anything, I mean, that's I mean, exactly the capacity. But in 1990, we know that no one knows what it's getting. Of course, I mean, there is a way, that's where for 20 away, rather buy a lot of Bitcoin, and where the Bitcoin is more, but there is by a while. Now let's go back to 1990. Oh, yeah, no what it is. I can never right? Not, of course, again, one way to detect malware is again static signature, but also I would say the most common way to detect malware today is analyze the memory trace of the software. Okay? Because this is something that just cannot be hidden. What you read and write to the memory to the RAM, still right? I mean, it's just it. The system code somehow can be obstacle. Right? I mean, for instance, I mean, if you how to say, I mean, if you really want to write the malware code, you never write something like this for the computer code the function like that, right? You write the function really very difficult to read with no meaningful name. Okay, so I mean, analyzing them is very difficult. With reverse engineering, I will go through the whole trace, really see what does the function mean. Right? However, I mean, memory trace is something you cannot modify. You read, you write value of file, which is memory block, you want it right based on the system. However, Okay, let's say how can we perform the malware analysis? How can we improve the malware analysis with knowledge graph? Okay. So we can do something with malicious ranking. Okay. So we can use a knowledge graph, sample invoke API, sample contact domain. Okay. This means that this kind of software, they invoke this kind of API. They send some data to this kind of domain. Okay. And we have the zip node. Okay. Which we know that they are probably malware. Okay, for instance, you send data to some domain, probably something wrong with it. Okay, and we compute the malicious right, and after that we embed the sample, and we compute the cosine similarity, for instance, between the embedded value of some software. You know that it is the malware, right? To the software that you are just have the subspecies, right? And yeah, that's the idea. Okay. I will skip this part. I will say so, because it's about the physical layer. The last thing. Okay. Before we have another short break or maybe longer break. To be honest, I've been talking. 2 sessions continuously is not easy. Okay, now we have the social engineering, and for everyone, probably you already know that. So what is the most effective way to attack the computer system? Or what is the weakest part of the computer, the security system? Human, right? Yeah, so human. So why I mean, for what the password we set up the MFA. Well, I mean, to be honest, I just go to read, right? And you know what? I check my document. Maybe because I'm usually quite small, but you know, I mean, you open the door. I mean, you go to the toilet and just open the door, or we forget to. I mean, lock out. I mean, it's all kind of small issue like that. And I mean, for 40 years, I mean, people realize that, of course, I mean, the most, the weakest part of the cybersecurity systems over human, right? So how to attack the security system via human is called social engineering. And to be honest, I don't know in Indonesia, I don't know if you ever heard about the story Cambodia, about SCAR center in Cambodia. I don't know if you have the but in Vietnam, they have quite a lot. I mean, they try to make a call to say, claim that they are police, you have to play somebody the same thing, right? Or, I mean, they call you, say that, hey, your kid is kidnapped, or I mean, you are winning, whatever. To me, this also surrendering, right? But then there's a victim, personally, I mean, they don't have to hide, they don't have to. No, actually, no problem with the side, right? They said, yeah, why not the cow? Right? So we have the same problem, huh? And to be honest, today is my company in Vietnam. I think this will have a job. Yes, in the TV, in the news, in our national TV, it said that the foster can reach only a staff member, but he earns 9,000 per month. I think after this kind of documentary, more people want to be foster, right? Okay. But anyway, how can we somehow use the knowledge graph to improve the prevention of this society? This is really a big issue, right? You see that today you are Facebook or something, right? So what do we have is, for instance, we have the phishing email. Today, I think phishing email is less people is using email. But people are using OTT, WhatsApp. Also on Telegram, and I has this blog Telegram last month, but we have to bring a lot of stuff on Telegram. Okay, they will ask you to deposit some money to receive some money. Okay, so we have the phishing email corpus or Telegram corpus. We have the social network interaction between human that is also quite popular in Vietnam, that we have a lot of phishing and kind of the food. We have CTI proven metadata, CTI cyber threats intelligence. Okay. So what is output? For instance, we have the social economic indicator. Okay. So how that work is, for instance, you can use the email knowledge graph, like sender to organization, email to link to domain, and the trust of the email is a sum of all the trust of the X, right? And after that, if the trust is so small, okay, you can write. So that probably is kind of phishing. In fact, in Vietnam now there are several organizations is trying to do so, build the alert system. Every time you receive the code, they will alert that this code is scam code. Yeah, but the problem is someone don't want to believe. I don't know why. Okay. So okay, it's the same story, right? Even in the wiki part, even we say that it's a scam, but if you don't want to believe, right? We cannot do anything, right? Also, another story is the brand pretend to be the US retailers. I mean, something kind of US soldier is now borrowing his single ways around. He has a lot of money. He just want to sell some beef in Vietnam for this girl, but you have to pay some money to for the important service. And then they do something again, and we have to have a lot of it. Okay, and the point is not because there's no alert, it's because people don't want to believe on this. And yeah, okay, whatever is only a human problem. Okay, so far we have went through, I think, 8, 9, 10 is very different to study in cybersecurity. I think it's quite diversified, and I hope now you have more or less. Even if you didn't do anything with knowledge around cybersecurity before, I hope you have a more clear picture, clearer. That's how can we, at least some starting point to see how can we use knowledge graph in cybersecurity. Yeah, in all kinds of domain, not only intrusion detection, but also in, for instance, security audit or social engineering, prevent detection of detection or something. Okay. I guess we can have another short break before we come to the final part. Yeah. Any questions so far?
Any question for the participant in this Zoom or in the Zoom? Maybe we have to break.
Huh?
You want to break?
Yeah, maybe we can have a short break. 10 minutes. 10 minutes. And after that, I mean, we go to the last one is some future direction where easier now. Future research direction means something, not like something we never do, right? We couldn't do because we don't have enough time money. And if we wish that, then it's something done for us, okay? And we go to a bit of time to see how we raise the price. Yeah.
We have break for 10 minutes. But if you have any question, can you directly raise your hand or chat in the Zoom?
kasih.
one part.
Yeah.
I give the opportunity again if the participant in this room or in the Zoom that is the question, application.
Yeah. Okay. So from probably for the next part, I will sit here. Yeah, getting out.
Maybe I have a question, Dr. Bill.
So
I think for me, honestly, is the interesting and insightful information because I not really know about the knowledge graph.
Yes.
So I think I have the basic question for your explanation. We use the LLM.
yeah.
And I don't see what in the step the LM used in this use
No,
case.
the LLMs basically is, I mean, after you have the result from knowledge graph, you just pass the result to the LLM with some prompt, state that, I mean, rewrite it in understandable text or something, and I mean, rewrite that. That's all.
But can we use LLM to define the knowledge graph?
Yes, we can. Definitely, we can. I will show that later.
So because you said the knowledge graph, the predefined is the most consume the time, and that is the like something we extract feature in machine learning.
Yeah, we will go to that. Yeah.
And if we compare to the machine learning or something traditional IDF, what the key benefit if we are using the knowledge graph?
Asset is we have the context, we know what really happened. Or maybe, let's say, we have the message, sorry, what's the name? Dito. I received the message from Dito. If I only see the message from Dito, I see that this is a normal message, I should receive that right. It, not the message here means the IP package, right? Dito send me some email, I should receive that because I don't have any contact. Dito seems to be a good guy, right? But if I have the knowledge graph, I can rewrite that the message of Dito indeed is received from another guy. And another guy received the message from another guy, and this another guy is turned out to be a malicious. And if we have a malicious graph, we say that hey, the message from Dito is malicious. But if we don't have malicious graph, we only look to the message of Dito. Yeah, Dito is suitable source, right? I mean, we have sent we have communicated for many years, and we know each other for many years. Probably nothing wrong with Dito. Right? That's a difference. Or let's say another example research graph is, let's say I'm internal database. And I mean usually if we say that hey, I mean this guy is an internal database, I mean instant in the local computer with no internet, I mean it's pretty safe. I mean if you have no internet, I mean no one can do anything with it. But turn out that Dito has access to me because he's a developer. He has access to my database. And now Dito also use another service. And this service has a vulnerability. And only with the knowledge graph we see that there is something wrong with the database. With no knowledge graph, right? Without the knowledge graph, we just see that yeah, I'm pretty safe. I'm staying here. I have no internet, right? I mean, so probably everything is good for me. Okay, so that's the main benefit of having research knowledge graph in cybersecurity. Yeah, I hope.
And I think in knowledge graph we get the reason or something about the conclusion or different with we are using the traditional.
Yeah, we can also do the explanation. We say that hey, we consider the email from Dito as a malicious phishing email because he received this email from Windows. Right, you can do.
You can say something like that, right? Rather than, training easy boost and just have the probability score.
But maybe depend on the situation.
Yes, indeed, this is really depend on the situation. Most of the time, we don't. To be honest, most of the time we never have the explanation. But it can be better explained, right? At least, for some uses, we can explain. What did you do wrong? From the knowledge graph to state ahead. Everything comes from the email, not from the website, not from the WhatsApp, but from email. So at least, yes, email is something wrong. Yeah.
But in the same situation and maybe apple to apple, if we compare, if you see traditional machine learning and knowledge graph, we can compare with the time of the effort to build the knowledge graph, or maybe
Again, knowledge graph itself is not a model. Knowledge graph itself cannot give you any conclusion. Knowledge graph is just knowledge, and based on the knowledge, you have to run different algorithms. For instance, here in this case, you have to perform temporal causal graph to really see what lead to the data leakage, or your computer is being hacked or something. Okay, so again, the knowledge graph we can consider is an addition to the database we usually have. Usually we have the database in the table format, right? It's a CSV or either in the SQL format. Now knowledge graph is something can be considered as an addition to improve the performance of machine learning. Rather than it's completely new, no, not really. It's just improve for the traditional machine learning. So you already have easy boost, you already have the SVM or something. Now with the knowledge graph, more or less we can improve the performance of easy boost as well. We don't replace them.
Yeah. And once again, in your presentation, you mentioned about the ontology.
Yeah.
In this case, what the position on ontology? Sorry, what the position in our use case?
For instance, let's take this one. We have the triple one access maybe conformal vulnerability. Where what is the VULN? Vulnerability. This comes from my first control. So we will show that and opportunity by some vulnerability and written as VULN. But so when you define the knowledge graph, you have to write VULN. You cannot write it into so okay, for instance, contributing 10% of efforts at people in programming. I said yesterday is that so it said that you have to write INT for integer. People you don't like why INT, but again someone already you have to accept. But if you don't like that, you don't use that, you don't like the program. But if you use that, you have to write INT for integer. Similarly, if you use stick ontology, you have to use a class defined by stick ontology. Okay, and let's assume that, to be honest, let's assume that it works for a company. Or another company, another organization, they already use stick ontology to define everything. Of the cybersecurity knowledge graph. Now you want to enrich the knowledge graph, you have to use the same ontology. That's all. Okay. Similarly, you have the legacy code already written in Java, and now you have to run. So you have to run. You can say no. I will use better than before.
It's not possible. Right? Similar for ontology. To make sure that anything is in the same level possible. Yeah. So here the assets come from the ontology, the depth of the ontology. You can call them BRIN. It's just a ontology. But I mean, in order to make sure that we have to buy everything from ontology. Okay.
So if we use the ontology, the knowledge gap is more.
It's more standard. Yeah. That's all. But otherwise, I mean, if people give the different name and different class type, and after that, I mean, we are done. Right? So ontology is just a standard to define the knowledge graph. In fact, ontology is standard to define something else. This context, let's talk about knowledge graph. Yes. For the first session, there are some ontology. Yeah, spec meter, UCOs, STE, UCO.
Yeah, so is the ontology we choose is different in terms of accuracy or quality?
Yes, indeed. In the definition, lesson, I'm trying to give a lesson. And in fact, let's say, if the ontology is one input computer, you have a computer.
Yes.
After that we cannot actually everything is computer. You have but when I and now we can actually define the beginning only one computer. That's no laptop is computer. PC is computer. Super computer is computer. Yeah. Right? So what we will do is similarly. Still, you want to define something which is how do you do that? 3 times. You cannot. Yes. Because we got the line.
So is there any method to measure the accuracy of the result?
Well, I would say, we actually to measure the performance of ontology. It's called something like you work at university. The style of Java and C is better. No one knows if you really something. However, we also measure by based on the stop fishing right? If you stop fishing more accurate than focusing on back and water.
And Mr. Bin, there is a question for the participant. Can knowledge reduce the false positive and false negative in equation detection?
The answer is yes. Basically, is why. The answer is why I said we need the knowledge graph in the context to the institution. The problem is you need the process and also why? It's a bit confusing. You have the really university of usually you have the network traffic of everything. Okay? So you know the picture. Okay? In practice, you only have the network to our computer. Right. So I mean there's a lot of missing links that we don't really know. For instance, I mean they go to ABC and maybe from C they go to us. We only have observed the network from C to us. We do not see the whole picture from A to B to C, right? So I mean there's a lot of missing. So in the question is under what context is under what scenario usually the requirement is we have the full picture. That is, to be honest, practically it's very difficult to have. Unless you are managing the system of the very big company or something, and so you receive the picture, right? Otherwise, what happened before they come to us, how can we help? For instance, you send me an email. And usually, of course, if the email comes from you, it's okay. But sometimes you forward the email, right? No, email is okay. But in WhatsApp, right? For instance, you forward me a WhatsApp message. I don't know where it's come from. I just see it on it. So I cannot analyze anything because I don't have the full context. So I cannot form any knowledge graph. Only Facebook can do. Because they own WhatsApp, no, not Facebook, Meta can do, because they own WhatsApp, so they have, and that's the idea.
Okay, yeah, maybe another question.
Okay. If so, we can always let the person at the end. I think let's go to the final part of this. Right. So, okay. So here is way to integrate the knowledge graph into the LLM. Okay. We go through that. We'll go through that as well. I will skip this. Okay, so we can also go to that. Now, let's go to the final part of today's presentation. It seems to us that knowledge graph is good, right? If you have knowledge graph, the question is how can you have a knowledge graph? At the beginning, we have nothing, right? So before the LLM, you have to form a knowledge graph manually, like that, one by one. Okay? What that means you have to write a for loop, okay? When you go through the whole data set, you add connection and entity to the knowledge graph one by one. And you have to process, you have to write some lambda function. Okay, you have to write some kind of manual processing by yourself to add the knowledge, to create the knowledge graph piece by piece by piece by piece. If you have 1 billion rows, if you have 1 billion rows, you have the for loop go to 1 billion rows like that. It's crazy, so right? But and also you have to write own kind of manual processing. Now, of course, we have LLM, so I will skip this part. No, there's some kind of use case with the Microsoft Security Copilot and hallucination. I will skip this, okay? So today, let me go through a quick a piece of implementation to see how can we create the knowledge graph, okay, with the LLM. Okay, let me zoom in a bit. So this is a demonstration I saw yesterday in the presentation. But now, forget it. Forget all the important something, right? I create a fake company just to test the knowledge graph, okay? Called Printech. And I create a fake organization structure of the company with the CEO and with the CTO and etc. So we have the knowledge graph to say that who report to who. Okay. And now how can we create how can we insert that to create a knowledge graph from this piece of text, okay? Before ever, you have to write a for loop, go through the whole document. And you have to write regular expression, if, else, to say that report to, and you have to extract all the text, and you have to write your own pattern, right? Well, it's not so good. But today, luckily, we have ChatGPT, okay? So everything becomes so easy. You see, I mean, it's a bit long, right? And you have to write it before, you have to go through the whole, either you create by hand, right? Or you have to write a lot of regular expression, a lot of parser to read who report to who, okay? Today, it is pretty easy, okay? You code graph document equal to, convert to graph document, and encode the GPT-4o or 4.1 or whatever model as a backend model, and everything will be converted to knowledge graph like that. Okay, so you see Mary and no, not this one. This is another knowledge graph. But anyway, the idea here is you can just code the Neo4j with the GPT as a backend, and basically Neo4j will try to invoke the ChatGPT as a backend to analyze the text, and after that create the knowledge graph. And after that, you can ask a question. You can ask a question like, after that, you can ask a question like, what is the message change from the CEO to Ali Rahman? And based on the knowledge graph, the answer will be the message change from CEO to Sarah Chen to Ali Rahman is Sarah Chen, Mascot William to John Anderson, Robert Chen, and Ali Rahman. And this is basically correct answer. Okay, and as I said yesterday, if we don't use knowledge graph, but we only use normal retrieval augmented generation, as I mean, many chatbots are using today, right? We have the wrong answer. You see that the answer is from Sarah Chen to Lisa Thompson to somewhere. That is basically not relevant at all. Okay, so the idea is using knowledge graph, you have a much better answer on the flow of the information. And also today, in order to create the research graph, knowledge graph, this is pretty easy, right? You just code Neo4j. I'm using Neo4j, you can use another library. And with the backend of ChatGPT, remember to make sure that you have the API key. And yeah, it will be done. Okay? I think it's also conclude my presentation today about the knowledge graph, security, and how can we create the knowledge graph. To summarize, let's say, not only intrusion detection, I would say so, but security needs to be context aware and needs to be explainable, right? I mean, sometimes we receive some email, or I mean, we install some application, and I mean the virus or just somehow said that you cannot run this program. It's really difficult, right? For instance, recently we had a problem with doctor. The recent doctor, I think 2 weeks ago, I mean, of course, I mean now if you will have doctor, what kind of thing you can do. But now, I mean, for some reason, doctor is prohibited by the virus. Program in Mac OS, so I think we cannot run doctor, so we have a lot of things. The problem is we don't know why. I know it. maybe doctor is wrong, maybe something wrong with the doctor, maybe something wrong with the new virus, protection, but maybe we don't know about. So more or less, the cybersecurity today need to be protected aware, need to be scalable. And one way, I would say one easy way to integrate the context aware and explainability to the cybersecurity system if you don't have a lot of money. By the way, now the question back to the very beginning. Why knowledge graph? I mean, why just feed the whole CSV file to LM, ChatGPT, right? And ask them, hey, or I mean, the whole email database, right? ChatGPT and ask them, it's an email. Right? I would say it's kind of natural process for today. However, we all know that I don't know what happened with the 5, but at least I mean for all 4.1 or all 2. We cannot. I mean, no LLM currently can process that we 1 gigabyte. I mean, and in practice we have much bigger. So knowledge graph is kind of more convenient and cost-saving way to represent the knowledge very quickly in the more structured way. Right? Before, I mean, you say that, yeah, because we have 10 gigabytes, 1 gigabyte data, but I mean, through everything to the LM retrain, everything, you can answer everything. But I mean, how many people, I mean, in the world, can have enough money to retrain 400 million people, right? But I mean, creating knowledge graph is somewhat easier and cheaper, but still more structured. You know what happened inside the graph, you know when who's connected to whom, right? So after that, we can explain. Even for LM today, of course, you have an answer, but we have no idea why. We have a lot of conversations. We have no idea why this answer like that. And sometimes we ask exactly the same question, we catch right. So knowledge graph and give us the power of explaining, but also the power to summarize. You say you have 1 terabyte, now you can summarize just one graph. And on the other hand, the graph theory has been studied for many years, 300 years, I think, 200-300 years. First problem is a 7 grades in commissioners and up to now 200-300 years. We have a lot of algorithm technologies to process graph rather than an LM, I would say so. So, but on the other hand, today I need to create the knowledge graph. So on the product, it's pretty easy, huh? With LLM. So I hope, I mean, and also we go through some use case in different use case running from the security management to actually very detailed technical tasks like physics implementation. And I hope, I mean, we have a clear view of the connection between knowledge graph and cybersecurity and the middle. I think this also concludes my presentation today. Thank you very much.
Thank you so much. Thank you very much for your excellent presentation. Any question in Zoom? Here. And there is the question from the participant, Mr. Bin.
Yeah.
Can knowledge graph reduce false positive rate become under 5%?
No, we never know. That's a problem. Again, I mean, knowledge graph is kind of machine learning, right? And today, up to 2025, we still need to use empirical risk minimization, right? Or empirical risk optimization, right? I mean, at the end of the day, I mean, long story don't short, long story don't read, sorry, is that, I mean, we never know. We have to actually implement, write the code, run the code, and see the output. No. So no way we can estimate the gain of any algorithm yet, given the data set. I would say it's a very interesting research
topic, but I don't see any breakthrough of that. So, for instance, if you have the new algorithm, you have one data set, and you really want to know, is algorithm good for this data set? The only way so far is we need to run the code and see what is going on. Okay, thank you, Mr. Good. And another question, do we need the other framework for explainable decision result? For example, explainable AI? Yeah, very good question. For the framework, I would say for the framework, we already have something like for the machine learning, for the traditional machine learning, we have SAP, that probably the most common one. For the deep learning, we have the graph clip or graph cam to explain the gradient when we train the convolution neural net. No, I don't think we really need anything else for the knowledge graph, because knowledge graph is very close to the natural language. I mean, if you look to the knowledge graph more or less, everyone understands that already. Now we just need LLM to rewrite that, but even if you don't use LLM to rewrite that, most of people can understand that you have from A to B, right? It's not A need to be, right? We have the entity right click to the email, and the entity is losing the password, and this is very clear for every human, right? I hope, but it's a bit clear, right? Okay, thank you, Dr. B. Any question?
In the Zoom, there is a question.
Yes, let me check. I'm also in Zoom. How about the future research direction about the knowledge graph? Future research direction. Very good one. Now I would say the future research direction is one thing is own way. How can we? First of all, we are. At least, from my point of view, in fact, as we share by, some of my friends, that, currently we are using LLM to create the knowledge graph, and then we use knowledge graph to improve LLM. It's somehow self-cycle. And who can verify the accuracy of the knowledge graph created by the LLM? Okay, so that is a very big question. Any comment, Mr. President? That's the problem. We have the LM to generate knowledge graph and how to make sure that knowledge graph generated by LM is sufficient enough. We also mentioned that the knowledge graph augmented models, which kind of models that can be augmented by the knowledge graph. Sorry, you mentioned about also knowledge graph augmented models, which kind of models that can be augmented by the knowledge graph. Wow, basically, so all the question answering model can be augmented by knowledge graph. Basically, on the query model can also be augmented by knowledge graph. For instance, today, how to say? So, for instance, today, if we are talking about multi-agent system, right? And if we have an agent to work with the database, for instance, this kind of agent can be augmented by knowledge graph for sure. Enough? Or any comment?
No more question.
No question. Any other question from the participant? Maybe there's no question. Mas Dito? Yeah, so if no more questions, I would like again to say thank you for the participation today. And after that, I mean, to be honest, I'm not quite sure. I mean, where will I be? Yeah, this afternoon, I mean, just ask Lyndon, right? I mean, if you want to have a, I mean, casual chit chat or something, I mean, yeah, I mean, just come and we'll talk. Yeah, thank you, Dr. Kun. Thank you for the excellent presentation. Is inside us, and we come to the end of the meeting. Thank you very much, and give a round of applause for our speaker and for all of us. Thank you very much. I will give back to the Ms. Kristanti. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
So, ladies and gentlemen, finally, we are now in the closing session for our Seri session 2025. With the topic knowledge and data engineering. On behalf of the organizing committee, we would like to express our heartfelt as appreciation to our distinguished speaker, Mr. Quang Vinh Dam from British University Vietnam, and also Mr. Wawan Hendriawanur as the moderator and as well as the participant. We hope the knowledge shared will be lasting benefit, and it has been our pleasure to host the event. Once again, thank you for joining and your active participation today. Have a great rest of your day. Wassalamualaikum warahmatullahi wabarakatuh. Thank you. Thank you very much. Thank you. Bapak Ibu, ada makan siang di belakang, silahkan diambil ya. Terima kasih.